Hello and welcome to Science Never Stops. I'm your host, Joseph Vick, Museum Education Manager here at the U.S. Space and Rocket Center. Today we are celebrating NASA's International Observe the Moon Night, sponsored by the Planetary Missions Program at Marshall Space Flight Center. International Observe the Moon Night is a time to come together with fellow moon enthusiasts and curious people worldwide. Everyone on Earth is invited to learn about our lunar science and exploration, take part in celestial observations, and honor cultural and personal connections to the moon. You can check out moon.nasa.gov/observe online and follow the hashtag #ObserveTheMoon on your preferred social media platform. Outdoors, at home, online, or wherever you may be, we're glad to have you with us. However you choose to observe, please follow local guidelines on health and safety. Now, in today's program, we have Marshall Space Flight Center planetary scientist, Dr. Caleb Fassett. Dr. Caleb Fassett is a planetary scientist at NASA's Marshall Space Flight Center. Originally from Maryland, Dr. Fassett earned his Bachelor of Science degree from Williams College in 2002, a Master of Science and PhD from Brown University in 2005 and 2008. His scientific research focus is on using a combination of remote sensing, geologic mapping, and numerical modeling to better understand planetary surfaces and geomorphological processes. He is also invested in how observations of impact crater populations can be used to infer the chronology and geologic history of planetary bodies. Dr. Fassett joined the Planetary Science Group at Marshall Space Flight Center in 2016 after 5 years teaching at Mount Holyoke College. In addition to science, Dr. Fassett supports NASA Marshall activities, including the Spaceflight and Payload Integration and Evolution Team and the Advanced Concept Office. Along with colleagues, Dr. Fassett works with these engineering teams to promote and advocate for science as NASA ventures deeper into our solar system. Welcome, Dr. Fassett, to Science Never Stops.
Thanks. It's nice to be here.
All right, so let's dive into our first question. With today being the International Observe the Moon Night celebration, what is your first memory of observing the moon and the impact it had on you now that you're a NASA planetary scientist?
I've been doing this as a scientist now professionally for 20 years or so, but I was an amateur astronomer as a child, and my next door neighbor used to pull out a telescope and let us look up at the sky. And I grew up in suburban Maryland, and so the moon was a particularly good target because it was always very light polluted, and so the moon's a great one with a small telescope or binoculars, or even the naked eye to check out. I've appreciated it for pretty much my whole life as a object to look at in the sky. And for me right now, as a scientist, one of the fun things to do with the moon is even just to see it with the naked eye, because you can see with the naked eye some of the landforms that I work on, like big impact basins. The Imbrium Basin just stands out. The man in the moon up there. So I've always liked seeing the moon, and my kids like it too. It's one of those sort of fun things about being a observer of the sky and the environment around us.
Could you elaborate for us on some of the research and mission work you do with NASA?
Yeah, so the main lunar research I work on is basically to try to understand how old surface features are on the moon and how fast the surface changes. And so you probably are used to erosion on Earth, where rivers and rain do a lot of the work. And obviously, there's no atmosphere on the moon, so that doesn't happen. But the lunar surface does change, and it changes in a sort of remarkable way, which is the small impact craters shape and reshape the surface as time passes. And so I try to figure out the rate that happens. It's an active area of research. We also try to understand the deep chronology of particular features on the moon's surface to try to understand how old they are. So because the moon has an old geologic record exposed to us and has been in the same space environment as the Earth, we might be able to learn about the early impact history on the Earth from looking at the moon. So those are the kind of topics I work on. In terms of missions, I am on a mission called Viper, which is going to be a rover that goes to the South Pole of the moon in the next few years. It's a really exciting mission. We've never had any exploration down there yet. And I'm also involved in helping to try to guide some of the science questions we're going to look at when we return people to the moon, hopefully to the South Pole as part of the Artemis program. So I have sort of a number of things I work on in terms of missions as well.
And speaking of the Artemis program, are you particularly excited as a planetary scientist about NASA's future efforts of landing astronauts again on the lunar surface to explore that polar region, especially in Shackleton Crater?
Yeah, so the poles of the moon are really special. They're neat places. There's parts of the poles that have light for a very long time, sort of similar to what you have on Earth, the polar regions during the summer. So they're neat places, and we've never explored there. And one of the great things about them is they're very far from where the Apollo landing sites were. And so if we sent people and we're able to gather samples from there, the moon rocks we would bring back are very different in type. And so as a geologist, that super excites me. It's a really fascinating potential. The particular big crater at the pole of the moon, Shackleton, we always talk about it as being like this place where it'd be really amazing to go, but it has a really, really steep slope. So I bet if we send people, we're going to be marching around on the rim of Shackleton or its surroundings rather than going down inside it where it's permanently shadowed. We'll probably stick to things like Viper or some sort of robotic exploration for places like that at least in the near future, because it's really hard for Shackleton.
So what would be your favorite scientific moon fact you'd like to share with our audience?
So the thing that gets me most excited, and this is something that is relatively new, is that we've actually observed directly impact craters forming on the moon. So there's several observatories around the world that have tried to do this, including at Marshall, where they monitor the surface of the moon for impacts, and they see the flash of the impact happen. And so that has been captured a number of times. I think more than 100 have been observed from Marshall. I don't actually know the number off the top of my head anymore. But in particular, a few of these have been pretty big. And so we've seen them happen, the impact flash event happen where the crater is forming, and then being able to take pictures of it after the fact with the Lunar Reconnaissance Orbiter. And as somebody who thinks about how the moon's surface changes over billions of years and let time happen slowly, having these events happen in real time is super amazing. And so there's an 18-meter crater that's through material kilometers away, and when we saw it form with a video, and then we were able to take before and after pictures with the Lunar Reconnaissance Orbiter. It was totally cool.
So you mentioned in real time, so you had the Lunar Reconnaissance Orbiter as it's orbiting, and it would notice these things, and it would record, or you would see these stop still frame images of it slowly going, or not slow, but then sort of that hitting and forming the crater all at once?
Well, I should clarify. So we didn't see the actual cratering event with LRO itself. We saw still pictures before the crater and after the crater with LRO. So you can see sort of the before and after effect with the orbiter. But what we did see is the event actually happening with a video camera through a telescope on Earth. So
wow.
Yeah. So the folks over at Marshall in the Meteor and Environment Office were monitoring the moon and saw the flash of the event. And so they were able to measure things like the energy that was associated with it and guess the size, and then go look and see how big it was. So it's like real-time investigation of the scientific hypothesis about how much energy is produced as light that you can see at the camera. It's really quite cool. We've floated a concept, and the Europeans have as well, to actually do monitoring from orbit like you're describing, where you would look for these events for flashes as they happen from orbit around the moon. But currently we're just doing it on the lunar near side from Earth. So it hasn't happened in lunar orbit yet.
So you're mentioning all of these various NASA projects and projects that you're currently working on. Where can our viewers go to learn more about the science you are doing with NASA?
So I do encourage everybody to go check out www.nasa.gov/Artemis, all lowercase for Artemis. because it really does tell the story of why and how we're going to try to get back to the moon. And so, we're actively trying to figure out details of the mission now and pick landings sites and companies that are going to build the lander, designs for this mission. And I think everyone out there should try to follow along because it's incredibly exciting. The moon is a big place. We've only been a few places with people. And to go back to this very unique environment of the South Pole of the moon would be very exciting. I hope everyone is paying attention. So that'd be the site I'd point people to. I guess I wouldn't point people to my articles in JGR Planets. I think that'd probably bore people to tears. But it is what it is.
I can hear your radiated passion through the screen, but you mentioned earlier about how the poles are very cool, but what is your favorite part or landscape or geographic region of the moon?
Yeah, that's an interesting question. So I guess I would like to go to one of the really big old basins on the moon, either a place called Smithy, which is a basin deep in time, way 4.3 billion years old, and walk around on the hills that still are sort of left over from that and try to pick up some of those rocks and figure out really how old are they, because we're kind of guessing right now. Or the biggest basin in the solar system, impact basin in the solar system, is called South Pole Aitken Basin. It has kind of a tongue twister of a name, but it's on the far side of the moon. It's 2,000 kilometers across, so it's huge. And returning samples of that and exploring that terrain would be just phenomenal. Of course, we've never really explored the far side of the moon. Apollo was stuck on the near side, and so there's some challenges with that in terms of communication. You need to have a way to talk to your astronauts, which is tricky on the far side. So the infrastructure matters in this case. Some of the South Polar landing sites that we're thinking about aren't. If you think about South Pole Aitken, it has South Pole in the name, so it does sort of extend from right at the South Pole up the southern far side. And so there's hope if you go to the South Pole of the moon that you could actually get samples of this impact basin. It's probably the oldest thing that's preserved on the lunar crust.
So is there a potential, I know with the Apollo programming in the late 60s through the early 70s, they brought back what they termed the Genesis rock, which was the oldest rock. So you think with the Artemis mission and human landings and bringing back samples, we could potentially find a new Genesis rock?
The funny thing is that pretty much since those Apollo samples came back, we've been arguing about the first 500 million years of lunar history. So, the Genesis rock, these 4.4-ish billion year old rocks that are probably the earliest remnant of the whole crust, the whole of the moon being melted, a magma ocean, an ocean of rock, melted rock, very cool, is neat. But actually getting samples of some of these early impact events, which are the biggest thing that matters for the in terms of the space environment early on the moon, is really important, and would also tell us a lot about the big events in terms of impacts that were happening on Earth, where we basically don't have any understanding at all. And so, I don't know if it'll be older than a Genesis rock or whether it'll, the key thing is getting rocks that we can tie to specific events with the moon, either crustal formation or particular impact basins or things like that. Some of the arguments about the Apollo samples really are basically the understanding where they came from. So the story of the rock. And the stories have changed since 1972 as techniques have changed and people have revisited analyses, and we've gotten better remote sensing data and all kinds of things. So it's really an active area of work.
So as a current NASA scientist, what advice do you want to give to the next generation of NASA scientists?
Yeah, so I guess my main advice is just be curious about things and try to learn as much as you can about lots of different things. A lot of people will say to become a world-class scientist or engineer, you need to specialize, you need to focus in and lock in on things. But that's not necessarily been my experience. My experience is that knowing a lot about a lot of things is useful, especially to understand the discussions that exist right on the boundary between different fields, and that's where a lot of the unknowns are often. So insofar as I'm capable of giving advice that's useful, I would say that'd be my advice, which is learn about whatever you find interesting, and then hopefully you find lots of things interesting, and don't feel like you have to just do one thing to become a scientist or an engineer, or even a communicator or a teacher, or any of the things that really are important when it comes to the future of science and NASA. And there's a broad community that really contributes to space exploration. It's not just a narrow set of folks.
That's very good advice. To be a good scientist, engineer, educator, you got to have a curious mind to explore the world around you. Or
yeah, that's right.
Other outer worlds close to us and around us. So thank you, Dr. Caleb Fassett, for joining us in our celebration of International Observe the Moon Night tonight.
Appreciate it.
So wanted to thank you all for watching, and thank you again to our sponsor, the Planetary Missions Program at Marshall Space Flight Center. We encourage you both, please go out and observe the moon, as well as go online to see other exciting virtual moon celebrations around the world at moon.nasa.gov/observe. Wishing all of you watching clear skies, and remember, science never stops.